Hi guys, today we are going to be reviewing for your quiz that's on Monday over Slope-Intercept. So let's go ahead and get started. So number one, Miranda needs to send a package to Nebraska. United Shipping Service charges a base fee of $10 plus an additional $3 per pound. So they want you guys to write an equation to represent the total charge of shipping a package for any weight with the United Shipping Service. So again, Slope-Intercept, we are looking for the form y equals mx plus b, where m is your slope and b is your y-intercept. So if they're talking about a base fee of $10, that means that that is our flat rate fee. So no matter what, you are going to have to pay $10 plus however much it is per pound. So this $10 is talking about our y-intercept here. So y equals, I don't know my slope yet, plus the 10. And then it says plus the additional $3 per pound. So that word per right there is our indicator of our variable, which means that that number needs to go with our variable, because if it's talking about $3 per pound, we could plug in any pound that we have for these packages, and then it will tell us our total after we solve it. So your guys' equation should be y equals 3x plus 10. Part B, from your equation, what's the y-intercept? Well, remember your b represents the y-intercept, so in this case it's 10. And then what does it represent? As long as you guys put something like it's the flat rate fee, or in other words, the starting price, you will be kind of correct. And then for C, what's the slope? Well, your slope is the m, so our slope is 3. And what does it represent in the context here? So the 3 represent how much it costs per pound. So very basic thing, your y-intercept is saying, all right, x is at 0. So if there's no charge or no pounds of anything, you still have to pay this $10 flat rate fee. And then the slope is representing for the amount of pounds, that's how much it's going to cost you. So it's the cost per pound. All right, D, if Miranda's package weighs 7.5 pounds, how much will she pay altogether? So all that we have to do here is plug in the 7.5 pounds for X. Since it says $3 per pound, well, 7.5 pounds, plug it in for X in your equation and then solve it. So this will be y equals 3 times 7.5 plus 10. And then get out my calculator here. If we took 3 times 7.5, you get 22.5, and then add 10 to it, and you should get 32.5. So this is saying altogether it's going to be $32.50 that she'll be paying. All right, next one. If Miranda pays $43.75 for her package, how much did it weigh? So now we're working backwards. So notice how we plugged in pounds for X because it was talking about the price per pound. But now they gave us the total. So looking at our equation, which one of our variables represents the total, the Y or the X? Well, we already said X was talking about pounds, so that means that Y is talking about our total. So what we're going to do is we're going to plug in 43.75 for Y, and I'm going to do it over here. And then write out the rest of the equation. And then notice how we're trying to solve for X, so we just have a basic two-step equation here. So our first step is to subtract 10 on both sides. We get $33.75 equals 3x. And then your last step is to divide by 3 on both sides. So if we were to take 33.75 divided by 3, we get 11.25. And this is representing the pounds. So it weighed 11.25 pounds if she paid $43.75. Okay, so that's the first problem. If I'm going too fast, remember you guys can just stop the video, but I'm just going to keep going, okay? So this next one, wind chill. This table shows a linear relationship between actual temperature and approximate wind chill temperature when the wind speed is 20 miles per hour. So we want to find the rate of change for these data, so the slope of the line. So remember, if we are trying to find slope of a table, we're looking for the change in y's over the change in x's. And notice how wind chill is your y values and actual temperature is your x values. So let's figure out the change in temperatures of the wind chills, since those are my y values. So if we went from -31 to -24, that is adding a 7 degrees Fahrenheit. And then -24 to positive or -17, that is once again +7. -17 to -10, that's +7. And then -10 to -3, that's +7. So your change in y's is 7 over your change in x's. Hopefully this one's a little bit easier to see. So every single time as you're moving up, you're adding 5 every single time. So your slope is 7 over 5. The change in y's over the change in x's. Next, I want you guys to write the equation in slope-intercept form. So remember, slope-intercept form is y equals mx plus b. We just figured out what our slope was, so we're going to plug in 7/4 for m, since m represents the slope. So y equals 7/5 x. And then we just have to figure out this plus b part. So remember, the plus b is where will it cross out on the y-axis. So if you're crossing on the y-axis, that means that your x value equals 0. And notice how our x values go up by 5. So it goes 5, 10, 15, 20, 25. Well, if we were to add one more column to the left of this over here, do you guys agree that if we're adding 5 this way, we would subtract 5 to go the opposite way? So if we took 5 minus 5, that will give us this value of 0, which is what we want to figure out what our y-intercept is going to be. Because, once again, if our line crosses on the y-axis, our x value is 0, and then our y value is wherever it crosses at. So whatever this number is will be our y-intercept. So same thing, if we're adding 7 this way, if we want to go the opposite way, we need to subtract 7. So if we were to subtract 7 from -31, we would now get -38, which is where the line will cross at on the y-axis. So our slope-intercept form equation is y equals 7/5 x minus 38. What's the y-intercept of this equation, and what does it represent in the problem? So we just found out that our y-intercept was -38. That's a semicolon, not a J. And then what does it represent? So it's representing when the actual temperature is at 0 degrees Fahrenheit, right? The actual temperature was at 0 degrees Fahrenheit. Where was the wind chill at? Well, the wind chill is at -38 degrees Fahrenheit. So guys, we're pretty much just looking, are you using the correct variables, talking about your x and y variables, and then representing it in the actual story problem here, okay? So when x was 0, so when the actual temperature was 0 degrees Fahrenheit, the wind chill was -38, which is where it crosses out on the y-axis, okay? And the next one, what is the wind chill temperature when the actual temperature is -5 degrees Fahrenheit? So now we're going to use our equation to help us solve this. So when y equals 7/5 x minus 38, they want us to figure out the wind chill when the actual temperature is -5. So since the actual temperature is represented by x, we're going to plug in -5 for x and then solve our equation. All right, so let's get out the handy-dandy calculator. So 7/5 times by -5, I got -7, and then subtract that from 38, and you should get -45, and that is your answer. So when the actual temperature is -5, the wind chill will be -45 degrees Fahrenheit. All right, and this last one on the front page, what is the actual temperature when the wind chill is 35 degrees Fahrenheit? So this is working backwards now. So now we're trying to figure out the actual temperature, which represents our x variable, and the wind chill is the y variable. So we're going to plug in 35 degrees Fahrenheit for y, and then solve the equation. Because once again, actual temperature represents x, so we're trying to find the x here, okay? So basic two-step equation, your first step will be to add 38 to both sides. So these cancel, you're left with 7/5 x equals, this is 73. All right, and then your last step to get x by itself is to multiply by the reciprocal on both sides. So when we take 5/7 times 73, we get 52.142857 repeating, so we'll just round it to 52.1. So let's put approximately 52.1. All right, so that is the front side of your study guide, if you guys want to call this. So to get the back side, you guys will need to go on to the next video.